Okay, so today we're talking about Chapter 10, Section 1. Let's make this big. Let's see, how did I do that? There we go. All right, so Chapter 10, Section 1, percent, sales tax, and discounts. So if you were kind of exhausted with the previous section, uh, this section is going to be more in line with what you expect from a computational mathematical course. As I've mentioned before, plenty of times before, what we saw in the previous section was more or less the heart of mathematics, but the term mathematics nowadays means computation pretty much. So we're going to be talking about computation today, talking about percent, sales tax, and discounts. So I think today's going to be super duper easy, super duper short, because these are definitely concepts that you know of. But let's begin here. Let's talk about percents. So percent, right? I'm pretty sure Latin per is like, I don't know, per whatever. Cent is 100. So the word percent means per 100. So if I want to find a percent, again, I think we have our little step-by-step algorithm here. But once you do it enough, you don't go step one, step two, step three. You just basically take the numerator and divide by the denominator. All right, you can multiply by the quotient if you want to, and I need to get my calculator out for this. Okay, you can multiply the quotient by 100, but again, once you do this a lot, you're not going to need to, and I'll get to what I mean by that here in a moment. And then step three, you just add a percent sign. Right. So this reads express 5/8 as a percent. So number one, express 5/8 as a percent. So 5/8 as a percent is going to be 0.625. Now, if we're looking here at step two, so we did step one. Step two, we multiply the quotient by 100. Now, you can, if you want to, take that number and multiply 100. Or, this says this is done by moving the decimal point in the quotient two places to the right. So we take this decimal right here, and we move it two places to the right. So it becomes it becomes 62.5, and then it says add a percent sign. And that's that. Now, I said that you might not need to do the multiply by 100 often, but here's what I do. I just look at it. So when we talk about percents, we're talking about a decimal, right? From 0 to 1, basically 1 being 100%. All the decimals in between, like 0.8, that's 80%. 0.543, that's 54.3%. Now, I will proceed with the rest of this section as multiplying by 100. But again, once you do this a lot, you're not going to necessarily do that. Right, next up, we're going to be expressing a decimal number as a percent. So what we're doing here is just basically we're doing the exact opposite. And let me get the problem up real quick. Alrighty. So this reads express the decimal point as a percent. So what we need to do here is we need to move the decimal point two places to the right and attach a percent. So basically what we did, basically it's the same thing we did in the first example, except we're starting with the decimal percent. We're not starting with a fraction here. Like we had 5/8 and then went to decimal, and then we took a decimal and put in a percent. Once we have the percent, we don't that stuff's pretty easy. Then again, like I said, you can go ahead and do it this way, and we will for this section. Take this decimal and go 1, 2, and we see that we have 47, and then we add a percent sign. But we could just simply look at that and just be like, oh, that's 47%. And look at that, we're 4.5 minutes in, and we've done the first two examples. And good news, the rest of the examples in this section are just as easy. So this is going to be a nice, easy breezy section to lead into fall break. Next up, we're going to be expressing a percent as a decimal number. So step one, move the decimal point 2 places to the left now. So now, if we're taking decimal to percent, we move the decimal to the right. That's how we go to the right. All right, going from decimal to percent, we go to the right. If we're already given the percent, well, then we just take the decimal place. And let's look at A real fast. Obviously, we don't. If we write 19%, we obviously don't see a decimal place. There's no decimal place, but there is an implied decimal, right? The implied decimal will be located right here at the end, and it'll just be 19.0%. So what we're going to do is we're going to take that implied decimal place and move it 2 to the left, 1, 2, and they'll have 0.19, and then we remove the decimal. I'm sorry, remove the percent sign. So it's 0.19. And I like to write 0.19, mainly because if I just write it like this, especially when I was taking this course and I'm writing it on paper, as I'm glancing through, I might skim over that decimal. Now obviously I can write it a little bit bigger, but I like to put a 0 in front, 0 point something, to really drive the point home that it is indeed a decimal place there. So 180, we have 180%. Again, we have that implied decimal place right here. We go 1, 2. So this is just going to be a simple 1.8. We can write 1.80, but it's really just 1.8, right? So that's the first three examples. We went from decimal to percent, and then from percent to decimal. All right, next up we're going to talk about sales tax. Now this is pretty important, and especially well, where we live, our sales tax is pretty close to 10%. It's almost it's like 9.975 or something like that. And so whenever I do sales tax really quickly in my head, it's pretty easy. I just do 10%. I say that because yesterday my wife and I went to Vera Bradley, and they had a deal. It was like I think it was like 50% off and then 30% off. But it doesn't add up to be 80% off. I don't know. Never mind. We'll leave it at that. It was really weird. It was really weird. It's like the way they did it, as opposed to just saying, yeah, you can take 70 or 75% off. It's like you take 50% and then 30%. I don't know. Anyway, so percent sales tax and discounts. We can obviously follow this particular formula, right? But again, it's not something that you necessarily have to memorize, because if you think about it, the idea of sales tax makes sense. So what it is A is P% of B. So if we say, that's dumb. Let's go down here. Sales tax amount. So sales tax amount is just going to be the tax rate in decimal form times the item's cost. And that's it. That's your sales tax. And so we'll do an example here to really drive the point home. We have example 4. Suppose that the local sales tax rate is 7.5% and you purchase a bicycle for $894. How much tax is paid? Now, again, when you do this, you have to multiply by the decimal form of the 7.5%. So what you're going to do is you're going to say 894, and you're going to multiply it by the decimal form is 7.5%, which is 0.075. Okay, and again, if you were to just imagine, let's do this 7.5%. I take this and I move the decimal form, or the decimal place 2 to the left, and it becomes 0.075, and that's what we have here. And again, I just put the 0 out front because it makes it easier on my eyeballs to see. So that's all you have to do for the sales tax. Let's do some behind the scenes calculating here. So 894 times 0.075. We're going to be paying $67.05. So $67.05 in tax. And then B reads, well, what is the bicycle's total cost? So the total cost is obviously going to be, the bicycle costs $894. We're also paying $64.05 in tax, and that would be plus 894, $961.05. Okay. So again, it's just one of those things that you've seen it before, you've probably done it before quite often, especially if you live in this area. You just take the amount, you add 10%, and that's it. It works logically like you would think it would. There's nothing extra here. Yes, yes. Mm-hmm. They're interchangeable. You can write 8 times 4 as 8.4, or 8 in parentheses and 4. They're interchangeable. It's just once we get to the point where we don't necessarily have to use the x. I don't, mainly because, as you know, x is used quite often in math courses as a variable, and I don't like to use it because it could be misconstrued as a variable. So I typically use a dot. Mm-hmm. Mm-hmm. It's a very good question though. Very very good. So this reads, none of us is thrilled about sales tax, at least I'm not, but we do like buying things that are on sale. Businesses reduce prices or discounts to attract customers and to reduce inventory. The discount rate is a percent of the original price. So what you're going to do, you're going to get your discounted amount is going to be the discount rate times the original price. And so you're again just doing the exact same thing, except what we're going to be doing is subtracting it in the end. Okay, so what I mean by that, let's just again think about this logically. Start with the problem. So the problem reads, a computer with an original price of $1,460 is on sale for 15% off. Okay, so it's going to be 15% off, so I know it's going to be less than 1,460. Well, if I were to follow along with this, the discounted amount is equal to the discount rate times the original price. So my discount rate is 15%. So 15% is 0.15. Again, please, I really do feel like you should get on board writing that zero first, but you don't have to if you don't want to. So 0.15, and then yeah, again, if I was putting x there, because as I've been there as a student, heck, I autopilot now as an instructor. Um, I might misconstrue that as a 0.15x, so that is why I do put a dot there, just to really drive the point home there. So 0.15 times what my original price is, which is $1,460. So I can do this one. So 10% of 1,460 is 146, and half that 73. And so we end up with a discount of $219. So we do the math there. We have $219 discount. Okay, and again, you can just put that into your calculator and you'll get it. So that's my discount. And then B reads, what is the computer sale price? So if the sales price is 1,460, and then I subtract my discount of 219, right, that would give me a total price of 1,241. Okay. And that's it. We take the total price, multiply it by the discount, and again, it's very very important. It's very very important when we talk about discounts or taxes or really anything uh, dealing with percentages. We always, 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 100% of the time, put them in decimal form. Always. If you don't put them in decimal form, you're going to get a crazy big, crazy large number, right? And of course, at that point, you should know, oh, I did something wrong, right? It's like if I did 1460 times 15, we're looking at what, 21,000. You're not going to get a $21,000 discount. So you'll know, hopefully. The logic will be like, okay, that doesn't make sense. The bike costs $1,460 and I'm getting a $21,000 discount. I don't know about that. All right, so percent change, uh, again, kind of in the same vein as, you'll know if you're doing it right or wrong, but it also does help let me to fully understand what you're trying to do here. So let me snip this whole darn thing. Okay, but the good news is that the if you're trying to find a percent increase and a percent decrease, the formula is the same pretty much, right? So if I want to find the fraction for the percent increase or percent decrease, it's just the amount of increase or decrease divided by the original amount. Super duper easy. Again, not obviously these things have to be kind of memorized, but I just feel like these are just one of those things that you just kind of as you do it, in 5 minutes, it's just going to come pretty natural to you if it is not already. And then step 2, find the percent increase or the percent decrease by expressing the fraction in step 1 as a percent. So we're going to take that decimal form and we're going to move the decimal place over, and then we're going to express it as a percent. So let's begin. Example 6. So in 2000, world population was approximately 6 billion, which is crazy because I remember like in 97 or something, I thought the 7th billion person was born. Oh well. Figure 2 shows world population projections through the year 2150. The data are from the United Nations Family Planning Program and are based on optimistic or pessimistic expectations for successful control of human population growth. Well, that last sentence doesn't scare you. I don't know what would. So A reads, find the percent increase in world population from 2000 to 2150. Use the high projection data. So we're using this blue line here, and we're going to find the increase. So what is the increase? So it looks like it's at, well, in 2000 it is indeed at 6 billion. Okay, so it's at 6 billion, and in 2150 it increases to 30 billion. Well, the difference there is 30 minus 6 is 24. Okay, so we would say, and let's just go ahead and write the 24 like that. So we would say the 30 billion minus 6 billion over the original amount, which is 6 billion. Okay, well that would turn into 24 divided by 6, which is equal to 4. Okay, well now for what? Well, again, it's wanting us to find the percent. So if I want to find the percent, I have to take this number and convert it to percent. Well, in order to convert it to percent, because right now it is in decimal form, but it's since it's over 100%, it doesn't look like it's in decimal form, right? But there is indeed a decimal right here, so we would say, okay, we'd take the decimal and move over 2 places, so we would say 400. So we grew 400%. Whoa, what am I doing? 400%. Right. That is the projection from 2000 to 2150 according to the high projection. Right. Now looks like we're using the low projection here, so give me a second. So B reads, find the percent decrease in world population from 2000 to 2150 using the low projection data. And now that's kind of scary. I couldn't imagine losing almost half well, a third of the world's population. But I don't think I'll be around in 2150. So same kind of procedure here. Again, we're wanting to find the amount of decrease, right? So we are decreasing. Our original amount is going to be 6 billion, right? So our original amount is 6 billion, and we're going to go down to 4 billion, and the original amount was 6 billion. Well, 6 minus 4 is 2. 2 over 6, or that's 1/3 percent, right? What? maybe I should do this. And I know 1/3 written in decimal form is 0.33, right? So, 0.3, yeah, 0.33, and just repeating. Well, how do I write that in decimal form? Well, it would be I would take the, let's do that in blue because we've been doing it in blue the whole time. I'll take the decimal and I would move over to my decimal point right here, and then I would say that I am decreasing over the next 150 years. I'm decreasing at a rate of 33 1/3%. Okay. Now, I wrote 33 1/3 because I'm pretty sure a textbook also did as well, but because if I take this number, 33 1/3, and then I multiplied it by 3, I would get 100%, right? But if I did 33.3, well, then if I multiplied by 3, I'd get 99.9%. So that's why I wrote 33 1/3, and I'm pretty sure that's also why the textbook wrote 33 1/3. It's more precise. And yeah, they wrote 33 1/3. Alrighty. So example 7, a jacket regularly sells for $135. The sell price is $60.75. Find the percent decrease of the sale price from the regular price. So we have to think about this again, just kind of logically. There's not necessarily too much computation outside of, well, the amount decrease formula that we saw right here. So if it sells at $135, obviously that will be the original amount, right? So that's going to be the denominator of my formula we saw on the previous page. So that's my original amount. The sell price is going to be $60.75. So find the percent decrease of the sale price from the original price. So we would say, okay, well, the original price was $135, and we're going to subtract the sale price now, which is $60.75. And we're going to do that arithmetic real quick. So let's move this stuff around so I can here. And so my numerator is going to end up being 69.25 all over 135. And that is going to be 125 by 135, 51.29. Wait, hang on a second. 130. What do you mean? No, I see what you're saying. I typed it in wrong. Yeah. Yeah, so that is a user error on the calculator. Yeah, I knew it didn't sound right because we want a nice round number for our percent decrease. So it's 74.25 divided by 135. So it's going to be that divided by 135. There it is, yeah. 0.55. So it's going to be equal to 0.55. So yeah, my first answer was it didn't look right, so I knew I did something wrong there. But 0.55, that doesn't tell you anything, right? I mean, we have to convert this to a percent, and again, we take this decimal and we go boop boop, and it turns into 55%. So we're saving 55% on a jacket, and that's pretty substantial, especially if at one point you saw that it was $135. My wife loves Old Navy, and if you go in there, they're always on sale. And I'm just like, well, if they're always on sale, then are they ever really on sale? I don't know. Yeah, but if I saw this jacket for 135 and then I saw it for 60, then I'm like, yeah, that's pretty darn good. So, uh, And then we got John Tesh. We're going to put John Tesh on blast in a college textbook. Poor guy. But that's what you get for getting on there and making mistakes, huh? So, John Tesh, while he was co-anchoring Entertainment Tonight, reported that the PBS series The Civil War had an audience of 13% versus the usual 4% PBS audience, which is an increase of more than 300%. Now, did Tesh report the percent increase correctly? Well, looking at it, you would say, okay, well, I mean, I can see where Tesh, what Tesh is doing here. He's saying, well, 13, it's over 3 times more than 4, so I'm going to say it's 300% more. But that's not how percentages work. So using just our formula from the previous pages, we're going to say that, okay, the original amount, whoa, that's not one. The original amount was 4%. Okay, so we're just going to write 4 there. And then the difference was 13 minus 4. Okay, well, 13 minus 4 is 9. We have 9/4. And 9/4 is going to be 2, let's see, 2.25. Yeah, 2.25. Right? And again, putting this into decimal form, we just move boop, boop. And so do we have 225%. So percentage-wise, the increase in viewership was up 225%, right? So John Tesh, obviously quickly was saying 13%, 4%, 3 times more. But again, that's not how percentages work. That's not how percent increases work. And so he would technically be wrong, but I don't think it's that big of a deal. I think any news media outlet that calls somebody out for that is kind of petty. And then last but certainly not least, my least favorite topic of all time is politics. And luckily, it's in my textbook now. So, a politician states that if you elect me to office, I promise to cut your taxes for each of my first 3 years in office by 10% each year, for a total reduction of 30%. Evaluate the accuracy of the politician's statement. And you know what? Come to think of it, my Vera Bradley uh, example earlier is kind of like this, right? So Vera Bradley was like, take 50% off and then take an extra 30% off. Well, you would think, okay, that's 80%, but you don't actually get to save 80%. And while I'm at it, let me just do the math and figure that out. So it's 75. So I'm actually saving 75%, or my wife did rather, and which, by the way, is still substantial, right? But if something's 50% off and then 30%, and then you take 30% of that, it's not 80%. It's actually only 75%. And this kind of ties into this example. So, uh, you know what? I think I went off the tangent too far. So let's read it. Let's read it over again. A politician states, "If you elect me to office, I promise to cut your taxes for each of my first 3 years in office by 10% each year, for a total reduction of 30%." Now that would obviously that's the statement we're saying is if it's true or not, for a total reduction of 30%. Evaluate the accuracy of the politician's statement. Well, we're gonna have to come. We have to have some sort of arbitrary number, and this arbitrary number we're gonna use is just gonna be 100 because 100 is a very easy arbitrary number to use. So, if his first year in office, second year in office, and third year in office, okay. The first year in office, if he's going to give a 10% decrease from an original amount of $100, well, 10% of $100 is $10. That's pretty easy. We don't have to necessarily do the math there. So my taxes my first year is going to be just $90. Good stuff. Okay. Next up, we're going to take 10% of $90. Well, 10% of $90, again, we're going to do 90 times 0.1, right? And that's going to be 9. Okay, so my taxes are going from $90 down to $81 now, right? Because 90 minus 9 is 81. Let's go ahead and erase that. And then next we're going to do 81 times 10%, which is 0.1, and that's going to just be equal to 8.1. Right? So yeah, 81 minus 8.1, 8, 9, 72, 72.9. Okay, and of course these are all dollars. So after a third year, my taxes are going from paying $100 down to 72.9, which is pretty substantial. All right, it's a pretty substantial decrease, but going from 100 down to 72.9 is actually only a 27.1%. Let's fix that one up. It's actually a 27.1% decrease. Again, substantial, but it is not for a, quote, total reduction of 30%. And so, naturally, the politician lied. And we're going to just do the bonus example of Vera Bradley, because I've talked about it twice, and I just really just want to point it out. So Vera Bradley said, take 50% off, and then another 30%. Okay, and again, still a pretty substantial sell, but as a consumer, you're thinking, man, I'm getting 80% off here. But Vera Bradley didn't say for a total of 80% off. So again, we're going to use our arbitrary number of 100. Okay. Well, if I take 50% off 100, that's pretty easy math. That's $50. And then if I take 30% of that, well, 10% of $50 is 5, and then multiply that by 3 is 15, so it's $35. Okay, so going from a total of $100 down to $35, that's actually, I think I might have said 75 a second ago. It's actually 65. It's actually 65%. Yeah, so I was mistaken there. I was trying to do stuff in my head, but as a consumer, you're thinking, man, I'm getting 8% off here, but realistically, it is 65%, which again is still pretty good, but it just looks so much better as a sale when you write it like this. It's kind of disingenuous, I think. Anyways, that concludes today's lecture.